Now we have implemented the two sort algorithms, a quick sorter, which takes array and size. Also earlier we have implemented the selection sorter, array and the size. Remember that selection sort, the time complexity is big O n squared, while quicksort is n log n. So quicksort is supposed to be faster. So let's do some automated test with the random data. So in main, let's do for that. And the things we have done is just to test while we implement the code. So let's comment it out. And what I want to do is as follows. So let's define a large number and then use this one. It's 100,000. Let's give a big number. And since we are going to generate a random number, let's call srand and time null ptr. So that's randomize the seed. Then we are going to declare an array size n, huge array, and then let's generate a random number. Int I is 0, I is n, I plus plus. Then data I is a random function call. And then let's we could use any raw number generated, but let's give some modulus, just n times 10. So only a little bit bigger than n, then that's the maximum one. So let's wrap it out that way. And then what I want to do is for the incremental size of the data, I want to compare the execution time between selection sort and quick sort. So let's do that. Int I, let's begin with 1000 data, and then just up to big number n we have defined, and then let's double each at each iteration. So 1000, 2000, 4000, and so on. Then what you want to do is since we have defined the shuffle function as a part of a quicksort already, so let's use a shuffle function we have designed, which is a prototype is not given yet. So let's copy prototype of the shuffle into array and size there. So void shuffle array and size. Since we have developed the shuffle by ourselves, we can use that. But remember, the algorithm library has a random shuffle function, which works the same way though. So let's shuffle the data with n size, the whole data. Let's shuffle that. Then let's take the elapsed time. So what I want to do is this is the time, elapsed time we get by calling elapsed time, and then call selection sort function first with array, but size is the increment I here is there. So we are going to design elapsed time function, and then first parameter is the sorting algorithm, so selection sort or quick sort we want to provide. So meaning that given the array with this many elements, just apply quick sort algorithm and then return the elapsed time for that. Then we are going to display cout selection sort with the I data, and then T is the actual elapsed time. So it's this many seconds elapsed for selection sort. And then we do same thing. So let me copy those three lines, and we want to repeat. So we shuffle the whole array again, but now I'm going to apply quick sort instead of selection sort. then the data is for quick sort, same thing. And then we can compare and display together, and then we can compare that. So let's implement a elapsed time function there. So it should be outside the main function. So double, it's a number of seconds for execution. Elapsed time. And then we are taking the function name. Then we need to define a function pointer. Function pointer, return type, and then pointer name is a sort, which is a function pointer. And then we need to provide a parameter of the function, which takes data array and then size of the array. That's the definition of the function pointer. First parameter, and then actual data array, and then size of the array. So that is what elapsed time function takes. So this, remember how to define a function pointer. Then in variable sort, we get either selection sort or quick sort. Now clock, remember how to measure the time in the earlier lesson, time complexity. We do same code, start clock, current clock tick, and then call sort, whatever sort is provided, and then data and size there. Then clock t diff is current clock minus start. So we measure the sorting time. Then return. Diff is integer, so we convert it double, and then clocks per second. If we divide that, this becomes a number of seconds there. So that's a elapsed time function. So let's test the code. Compile, and first error, use of undeclared elapsed time. Elapsed time means 24 elapsed time, and prototype is not provided. So let's copy prototype and then paste it. Name of the parameter is optional, so let's delete parameter name. Then a little bit harder to read though, but this is a professional style of the coding. Prototype of elapsed time is given, and then 28 t is declared again. So I don't have to declare t again. And then let's see if any more error exists. No, there is no error. Now let's run the program. Then here are the result. So the result says that selection sort 1000 time, quick sort 1000 seems less. 22,000 the selection sort, quick sort 4,000 selection sort, quick sort 8,000, compare that, and 16,000 quick sort, selection sort. So quick sort works far better. 32,000 selection sort, quick sort 64,000 selection quick. So you can compare those time difference. So as you can see, quick sort is much better in terms of performance, as we have studied the time complexity. Selection sort is n squared, but quick sort is n log n.